So, great. Basically, it's a weighted average of all the sums. That's why it's an average. It's like, so this, it's going to be like this times this. So, because it makes logical sense. Because the probability of this one happening is this times this. The probability of, and if you add all those probabilities up, you will get a probability that is the average probability, or it will be the average return. So, sum product. I mean, it doesn't matter, like, which order it's in. It doesn't. You could just select all these, comma, select all these. So, like, they had to make it a little too complicated. Like, what they should have just done is just select all these, comma, select all these. But anyways, I think that'll be fine. Okay. Yes. Squared deviations equals C4 minus mean. Okay. What they really mean, Dude, what the heck? What is this? What the heck is this? What? B11. Mean. We already calculated the mean. That's what this is, right? Whoa, C4 minus mean. What is C4? What? The maximum one or something? They just do C4 minus mean squared. What? B12 variance. So they have the maximum thing here. Like, what? What? C4 is this. C4. Oh, never mind. What they do is it's not just this. You do this number minus the mean squared. Oh, that's very intuitive. I guess that makes sense. Of course. Like, these are squared deviations. Sum product, and then variance, we're going to have squared deviation from mean, all these multiplied by probabilities. So this multiplied by this, and you'll get that. Okay. So I'm understanding what's going on. That was fine. Oh, wait, what? You could skip the calculation of the square deviations and use equation 5.9 directly. So what you would do is you would do market return, comma, because that would square it automatically. Wait, what? What? Why would you do that? Twice, you get the squares. Oh, okay. So basically, market return, probability, subtract mean squared. So there's a couple different ways to do it. You could do 2 and 3 to get the answer, or you could do this and this to get the answer, or you could just do this without having to do both of these. So that was fun. Standard deviation, square root of variance. I get it. Hilariously, we still have a few more pages to get to. Although it's just 2 more pages, actually, right? So we just have... Weirdly enough, there must only be 5. Mean return is 15.3%. Standard deviation is 5%, 5.3%. Expected return, it just means that (5.3b). So we only have 198, 199, I think, and then we're finally done with this reading. Then we got to do the quiz, and we got to do the homework assignment. And this will be the first time doing the homework assignment without a helpful video that the professor gave for the first 2 assignments. So it could be hard. That was funny. Could be quite hard to do. I mean, it's probably going to be kind of hard, considering that basically she gave us the answers for the last 2 assignments. I didn't just copy the answers, I actually worked through the problems, but it's still helpful. This is such a fun time. That was great. Anyways. Motivate. You have either awful, stable, or great. Okay, if the economy is awful, the mean and standard deviation are these two things. If it's stable, it will be these, and if it's great, it will be these. Woo! Unconditional mean was it before we learned the state of the economy. So hey, look, it says this is optional. Can we just do this as an optional section? They think it's advanced to do this. So wait, I wish it would be. So multiply this 2 plus multiply these 2 plus multiply these 2. Why is it a negative 20%? Oh, wait. Because the number they gave was negative 20%, right? So this times this plus this times this plus this times this or something. Okay, I think that's it. We're done. We're done reading. At least we're done reading. Okay. I'm going to look at the presentation because for the last stuff, I actually didn't read the chapters. I read the presentation. So it could be useful if I'm having trouble on the quiz. Maybe I'll find some information on this presentation. I don't think I need to read through this again. In fact, maybe I should have just read this originally. Dude, there's so much extra stuff in the presentation. What the heck? Wait, I'm an idiot. This is the whole chapter. I only read 3 parts of it. So anyways, I can look in the book and in the presentation for finding answers to the questions to the quiz if I need to. Because I'm assuming it's open book because it was not stated anywhere at all whatsoever whether it was open book, which I'm assuming means it's open book. Odds for 2 dice. We're not going to need that for a quiz, are we? I'll keep the page open in case I need it, but now these could be helpful videos for doing the questions as well, but there's a lot of videos. Okay, well, I got kind of lucky in the past 2 quizzes, but is my luck going to run out? That was funny. Is my luck going to run out this time? Yeah. Great. Quiz. Are we going to fail the quiz? Are we going to fail the quiz? Are we going to fail the quiz? Are we going to fail this presumably open book quiz? Because that's why I'm using the books, because I'm assuming I never even asked the professor. Like last semester in the summer class, I asked the professor because it was the exact same situation. It was never stated anywhere whatsoever whether the quizzes were open book. And it turns out they were open book. And it actually cost me points on the first quiz because I assumed it wasn't open book. And then I got like 3 questions wrong on that quiz. So I should be good for this quiz. I think I should be fine. I was about to procrastinate, but I was just... and then I just clicked begin. Great. Probability... Okay. Is the same as probability of A if given B. Oh, great. Oh, great. It's the same. I think it's independent. If probability of A is the same as probability of... Oh, dude. This is fun. I'm going to come back to that one. A discrete probability distribution. All the possible values. It's got to be that. Discrete probability distribution. Hey, how is it not here? Account. That was funny. That was so funny. Okay, if they are collectively, what is the probability that one or the other occurs? 1. The formal way to revise probabilities based on new information is to use Conditional? I think it's conditional. Yes. See? Stop. Best describes the concept of probability. Measure of the likelihood that something will occur. It would seem to be 1, right? Dude, they don't even have a... a number between 0 and 1 that measures the likelihood that some event will occur. Measure the likelihood that a particular event will occur. Following statements are true. The sum of all probabilities for a random variable, they cannot be negative. They cannot be greater than 1. Sum of all probabilities must be equal to 1. What is this rule? I think it's complements. I think it's complements. P of not A equals 1 minus P of A. So complements, right? Can be estimated from long-run relative frequencies. Objective. I believe it's objective. Oh, great. Estimated from long-run proportions. Objective. Probability of an event and the probability of its complement, they always sum to 1. A and B be the events of they are approving or rejecting a new drug. They either approve it or they reject it. They are mutually exclusive because you cannot both approve and reject it. It's mutually exclusive. And I think there's only one I didn't answer. So P, probability of A equals probability of A given B. I'd say independent because I was confused because it didn't say both A, B, and A given not B. I'm saying not B. I don't think that's the proper way to say it. How to say A with line above. It's probably... Nope, that's not it. But anyways, it's independent because it doesn't matter whether it's if B happens. They're both, it doesn't affect it, so it's independent. Please be right. Oh, great. $20 out of 20. Wow. Now I just have the homework problems. I don't know how many problems there are. I have homework problems. I don't want to do it. When is she ever going to grade my assignments? Only 3. Oh! This is not bad. This is only 3 problems. That's so easy, actually. I'm hoping it's easy. Problem 6, 8, and 9. Oh boy. Okay. There's only 3 problems. I can get this done. There's only 3. It's only 3 problems. Come on. Just problem 6. Problem 6 is, in fact, 2 of the problems are right here, but problem 6 is probably right after section 5.2. So if I go to the beginning of section 5.3, and then there it is. I found it. Oh, man. Oh, that's a lot of words. Good job. Good job. So come on. This is like simple stuff. This is not even that hard. It's just kind of simple math stuff. That was funny. You sniff. What does it say? What does the problem say? 6, 8, and 9. There are 2 types of beer, regular and light. Marketing department wants to verify that its traditional approach of appealing to local white-collar workers with light beer commercials and appealing to local blue-collar workers with regular beer commercials. Randomly selected group of 400 local workers are questioned about their beer drinking preferences, and the data in the files obtained. Okay. Oh, this is so hard. It's not hard. Come on. The probability that a blue-collar worker is chosen. Oh, no. Oh, dang it. No, I feel like I don't know how to do this. B and W, L and R. And what does B and W stand for? Oh. Light, regular, and not beer. No beer. I have gotten 0 feedback on any of my previous assignments. None of them have even been graded. Or how do we do this? How do we do this? Oh no! What is the probability that he or she prefers light beer? If blue-collar worker is chosen, what is the probability that he or she prefers light beer? Oh no. What is this equivalent to? What is this problem equivalent to? Do they have an example that's similar to this? Man, this is why I need the video from the professor. It's taking me longer to do this question because I don't really know what to do. No, it didn't explain how to do this question. It didn't explain. It didn't explain. It's the probability. No. What they're asking is, what is the probability that if this happens, what is the probability that what is the probability that if you select a blue color worker, isn't it just like the number of blue collar workers that prefer light beer divided by the number of, or divided by the total amount or something? Like, yeah, but yay, this typical textbooks. Typical. It's just typical. It's just typical that it doesn't have any example problems that are similar to this problem. This is crap. This is some crap. This is crap. We just have to figure out the number of things, number of B and something, but I don't know how to do that. Dang it. Dang it. I wonder if the PowerPoint has more information than the textbook. Dude. No. This is what happens. This is what happens. Like, maybe this will help, but I don't know.
If you want to download this workbook and follow along, click on my YouTube channel at the class. Just go to our Chapter 4 website. Now we're going to consider an experiment.
Man, this is old. How old is this? 11 years old? You really had to link us an 11-year-old video? How helpful that is going to be for us when we're using a version of Excel that's literally 11 years different. That was funny.
Of tossing a coin 3 times. Now, let's remind ourselves what in the world an experiment is. 1, it means 2 or more possible outcomes. One of them have 3 steps because we're going to flip the coin 3 times. Outcome on step 1, 2, and 3, each 2, 2, 2. So we can get head, tail, head, tail, head, tail. Total experimental outcomes, as we saw in the last video, the formula is just multiply all of the outcomes on each step. So we just need to take the product of 1, 2, 3 number 2s. Now again, in this example, the outcomes are the same on each step. Sometimes they're not. Here's one way to do this. We'll use the product function. Product function just takes all of the inputs as a range and multiplies them. So when I hit enter, I get 8. 8 total sample points in our sample space. Remember, the sample space is all of the sample points. Now, relative frequency or
why is this so old? Seriously, you had to link us this old video? I mean, maybe somehow I could find it in there, but like, I feel like what I'm about to do is going to be an inefficient way of doing it. Because the textbook doesn't explain how to do it. It does not. The textbook doesn't explain it. I bet this is not going to work. This is not working. Type. Preference. This is probably wrong. This is probably wrong. That's not right. How do I count the number of BL or whatever? How? This is not fair. It didn't explain. It was not explained in the book at all how to do that. It was not explained. It was not explained. It was not explained. It was not explained. This was not explained. What I need to do is how many B and BLs are there? That's all I need to find out is how many BLs are there. Divide by how many B's are there total. I mean, I know a way to do it, it's just inefficient. Apparently the pivot table thing is not working. I feel like this is going to be inefficiencies. Because this is inefficient because the book didn't tell us how to do it, so screw this crap. Screw this. Screw this crap. This is some crap. This is some crap. Now we have the total. We have all of these. And we just need a count. It says count 336. Already it says. Hey, it was 336 and now it's 333. That must be the number of cells, not the number of... Oh, okay. Well, this is extremely inefficient, but we're going to count how many of these there are. And it says there's 111 down there. I hate this. I hate coming up with my own solution that's inefficient because it doesn't give me an actual way to do the solution because it's stupid. 111. There are 111 total. BL is 111. So total. So if you select B, blue collar worker, you need the total of blue collar workers. And then that will give you, so again, like, Now, we will actually filter for clear filters and then redo the filter. And now the filter will only only include the blue collar workers. And then we will maybe we don't even need to copy and paste, because watch this. Right now we have select all. There's a total of 400, obviously. But if we select only the blue collar workers and then we select all again, it has 250. See, so we don't even need to copy and paste it into another tab. So we get 250 there. This means this crap is completely useless. So, whoops. So total B is 250. We already established, we've already filtered it by B. There's 250 of them, so 250. So also we're doing, I guess we'll now put the fact that we're answering number 6 right here. So we'll just put 6. So A is the probability that somebody who's a blue collar worker will prefer light beer. So A, the answer for A is this divided by this. Now, this is probably not how you're supposed to do it, but I don't know how I'm supposed to do it, so too bad. I'm just doing it this way instead. Hey, look, it's exactly 0.444, so we may as well just go like this. We have figured out the probability using a very convoluted method that is probably not what we're supposed to do. I hate myself. It wasn't even that hard of a method. It just doesn't feel right, because if a white collar worker is chosen at random from this group, yes? Hold on. I feel like I'm doing it wrong, gosh dang it. The probability of A given B is the probability of A and B divided by the probability of B. Maybe this is what we're supposed to be doing. The probability, what is the probability of A? What is the probability of light beer given that you have selected a blue collar worker? What is the probability of selecting what is the probability that you have both selected what is the probability of light beer considering that you have selected a blue collar worker? What is the probability of light beer and blue collar worker? What is the probability of selecting somebody who prefers light beer and they are a blue collar worker divided by the probability that you will select a blue collar worker? What is the probability? The amount of blue collar workers who prefer light beer divided by the total amount of blue collar workers is how I did the problem. Are we supposed to do the problem like this? Because the probability, it's asking, what is the probability of A given B? What is the probability of selecting somebody who prefers light beer given the fact that a blue collar worker is selected? Probability that both A and B occur. We don't care about that. Well, we need to know that apparently. What is the probability that both A and B occur? Well, we already know it's 111. Probability of A and B is we already have it's going to be equal to 111 divided by 400. Probability of just B. Well, the probability of B, we established that B is the thing that they gave us, and that is getting a blue collar worker, and the total amount of blue collar workers is 250. So it's going to be 250 divided by 400. So the probability of A given B is this divided by this. So this divided by this equals this divided by this. See, look, I didn't even need to do that. Was that a simpler way to do the problem? Probability of A and B is 111 divided by 400. Probability of B is 250 divided by 400. You know what's hilarious? Maybe that was the correct way to do the problem. But both ways are correct. Both ways give me the correct answer. It's just like... If a white-collar worker is chosen at random from this group. Okay. Probability of A and B. So... they're making everything overly complicated. The number of white-collar workers who prefer light beer. $79. The total amount of white-collar workers is... So, any preference? So the total number of white-collar workers is 150. Don't you just love wasting your life? You must love wasting your life. Probability. Hold on. No, there's part D and C. E. Only restrict your attention to workers who like to drink beer. Okay, so now clear filters again. Restrict your attention to people who like beer. Wait. Therefore, you must deselect N. N means no drink, not drink beer. Now we have restricted our attention to that. Good. Now restrict your attention. So now we have restricted our attention to people who like to drink beer. So what is the probability of all those people? So the number of people who drink beer, the number of people who like to drink beer is equal to R and L likes to drink beer. The total number of people who like to drink beer is 371. And then blue collar worker oh crap, this is more complicated. No. Wait, no it's not. Blue collar workers. Blue collar workers. The number of blue collar workers who like to drink beer. We have already filtered for the like to drink beer, so now we will filter for only the blue collar workers. So that should give us the total of 233. And then blue collar workers who prefer light beer. Wait. Because the total number of B originally was a bigger number. You know what, we're gonna switch this back to what it was originally. This was BL. BL was 111. This was B. This was 250. Just to make everything simpler. Well. Likes to drink beer. There are a total of 250 blue-collar workers, but only 233 of them like to drink beer. Watch this. Likes beer. All of the total people who like beer is this. The total amount of people who are blue-collar workers and like to drink beer are this. Blue-collar workers who like beer. We already calculated that as 111. Wait, so which number is extra that we don't need? The 371, we don't need that because we're not looking at the entire population. We're only looking at the blue-collar workers who prefer light beer. If you restrict your attention to workers who like to drink beer, what is the probability that a randomly selected white-collar worker prefers to drink light beer? W who likes beer. The amount of... We will just undo all the filters again. Never mind. It is now currently selecting those who like beer. We now will switch this from B to W. And now it should give us those total amounts. So, it's already selected. We may as well just do it again just to be safe. And 138. It logically makes sense because this total should be 371. And we already got that, so good. NWL, we already calculated that. Should be 79 because white-collar workers who like light beer. So D is this divided by this. I'm probably not even solving the question the way they want you to. Man, I feel horrible. I wish the professor had given us a video. That took forever. Wait, that's the whole problem. That's literally the whole problem. I don't even need to separate stuff. That was completely useless. Putting this here was useless. Putting the borders was useless. Because we're only doing one problem per Excel sheet, so... Man, I feel this does not feel correct, but unfortunately that's the best I can do, so... Oh, we finished 1 out of 3 questions. Hilarious.